Okay, let's graph a tangent function that has a whole lot going on. So in this case, we're trying to graph -2 times the tangent of pi times x plus pi minus 1 on the outside. So as we get going on this, what I'm going to try to do is break this down into, we have some vertical transformations going on and some horizontal transformations. Let's get some labels for our axes first, and then put it all together into a nice graph. So as we get going on this, the first thing I'm going to go ahead and do is just a little bit of factoring on the inside there. So as you can see here, we can write this as -2 times the tangent, and I'm going to factor out a common factor on the inside of pi. So if I pull out that pi, that's going to make these transformations more evident exactly which direction things are going to be moving. So I factored out a pi from each one of these terms on the inside. That leaves us with x plus 1. All right, so as kind of label these things attached to the outside of the function or the entire function affect this vertically. Multiples or additions attached directly to x on the inside of the function are going to be horizontal sorts of shifts. So let's kind of go through one at a time and talk about what each one of these different components does to our graph. So we have a negative out in front. What that's going to do is that's going to be a vertical reflection. That's what the negative's doing out in front. Next up, we have that 2. That 2 is going to be a stretch. It's going to make the entire graph be a little bit taller and skinnier as we go along. All right, that -1 at the end, that's going to be a vertical reflection because it's attached to the entire function. That's going to move everything down 1 unit. Okay, the other stuff we have going on here, we have this pi on the inside. That's going to affect our period. And then finally, we have that +1 on the inside. That's going to be a phase shift or a horizontal shift. That's going to move everything to the left 1 unit. All right, so first let's focus on the vertical component, so our y-axis. This stretch by a factor of 2, what that's telling me initially is our key points are going to be at 2 and -2. That's just based on this 2 here. We're also going to invert our graph using this vertical reflection out here in the beginning. We'll do that as we graph the thing. All right, but don't forget about that vertical reflection. It is important. Next, let's apply this downward shift. So everything's supposed to move down 1 unit. So for each one of these labels, I'm going to subtract 1 from them. These are going to put our labels at 2 minus 1 makes 1. -2 minus 1 makes -3. So those are going to be key values for us. I guess the other key value I'll go ahead and include here is that middle point. Initially, it was at 0 at the origin, but we're going to move that down 1, so it's going to go to -1. A third point, all 3 of these y values should be included as we put this all together for our graph. All right, next up, what I would do is go ahead and work with our period next. So the period has been affected that we have this pi on the inside. That's going to change our period. So the period normally starts out, and for tangent, it's typically pi. That's different than sine and cosine that are normally 2 pi for their period. So you start with the original period, pi for tangent, and then you divide by this multiple that's on the inside. So our period in this case, pi divided by pi makes 1. So how that's going to affect us is we're going to go from -1/2 to +1/2. Now this is not taking into account the leftward shift yet. The other key values that we'd like to have here are in between -1/2 and 0 is -1/4. That's where one of our key points would typically be. And then +1/4 is going to be between 0 and 1/2. All right, so these outer values, these are where our vertical asymptotes go. And then each one of these inner values are going to be key points that we're going to track around as we try to graph this. The last transformation we need to do is apply this, moving everything to the left 1 unit. So we need to subtract 1 from each and every one of these labels. So I'm going to use decimals to indicate these. So we have negative 1/2 minus 1 more makes negative 1.5. Negative 1/4 minus 1 more makes negative 1.25. 0 minus 1 makes negative 1. 1/4 minus 1 makes negative 0.75. And our last label, 1/2 minus 1 makes negative 1/2, negative 0.5. All right, now that we have all of our labels, let's go ahead and put those on our graph and put this all together. All right, so our x values, we have negative 1.5, negative 1.25, negative 1, negative 0.75, and negative 0.5. And of course, as we put these on a graph, those are all negative values, so they should be on the left-hand side of where the origin's at. All right, next our y values. We want 1, negative 1, and negative 3. So we have 1, negative 1, and negative 3. Okay, and then we just kind of have to put all of these key values where we need them. All right, our key points and our vertical asymptotes and whatnot. So at these extremes, at the left-hand label here and at the right-hand label, these are going to go as vertical asymptotes. So I'm going to indicate those with vertical dashed lines going through here. This middle label, that goes along with that point that was normally at the origin, but it's going to be here, and then this middle label here. So at negative 1, negative 1, we're going to get a key point. The other thing to remember as we're graphing this out and putting our other 2 key points on here, which will be at negative 1.25 and negative 0.75, is instead of this graph increasing the entirety of it, like our normal tangent graph would, what's happened here is, remember, this has been inverted. It's been flipped upside down by this vertical reflection out in front. So since it's decreasing the entirety of the graph, what happens is this left label here, the negative 1.25, is going to be up here at positive 1. The right label, negative 0.75, is going to be down here at negative 3 at that bottom label. All right, so the rest of it is basically just connecting the dots. Sorry, this should be decreasing. And of course, it's not going to look pretty. But as we get to that vertical asymptote, it has to keep going down. On the left-hand side, as we approach this vertical asymptote, it has to go up. All right, it's not the prettiest of graphs, but hopefully determining all these labels, that's the big key on getting very good graphs here, even if you're not a fantastic artist like I am. But hopefully we can graph these by taking our time, getting the labels, and making sure we understand exactly where each one of these transformations is going to affect our graph. All right, good luck. Hope yours looks better than mine.